All right, guys, we are back. We're finishing it off here. I did do this correctly. I was making sure that I hadn't done something wrong. But we end up, right, we plug in our numbers, we get a pH of 9.38. So now, right, we're asked to calculate the pH of a buffer after 25 milliliters of 0.5 molar HCl are added. Okay, so the key piece that we need to notice about this is that we have a strong acid. So remember, right, strong overcomes the weak. Okay, so if we have our chemical reaction again, right, NH3 plus H plus, or H3O plus, we are going to have an equilibrium of NH4 plus and H2O, right? Or since we have a base, strong acid, right? Conjugate acid, right? And we could do H3O plus there, right? So, right, again, the strong overcomes the weak, right? We're going to go towards this side. So we are going to gain some NH4 plus and we're going to lose some NH3, okay? So how much we can calculate from this. So 25 milliliters, 0.5 molar, so 0.500 moles per liter times 0.025 liters. That's going to be equal to 0.5 times 0.025, 0.0125 moles, right? So we're going to run to that side, right? Strong overcomes the weak. So our NH3 concentration was 0.625 minus now 0.0125, right? That we're going to lose. So that's going to be our NH3 moles. Our NH4 plus, right, is going to gain all of that. So 0.467 plus 0.0125. That's going to be our NH4 plus moles. Okay, so now we can go and we can plug in to our Henderson-Hasselbalch equation again. pH equals pKa negative log of 5.6 times 10 to the minus 10th plus log of A minus, which would be 0.625 minus 0.0125 over 0.467 plus 0.0125. So if we go ahead and we solve that, right, and I think I got that right, it should be 9.36. So even though we added a fair bit of our acid, right, we should have, we haven't really changed that pH too much, okay? So the buffer capacity is really just saying, hey, how easily can we change that pH, okay? So the buffer capacity, right, we can, if we increase the amount of our acid and conjugate base, right, the components of our buffer, that's going to increase the buffer capacity. It's telling us how easily we can change the concentration, okay? So at the moment, right, we had more of the NH3, which would be our conjugate base, or the base of, and then our conjugate acid. We had more of that base, so it's going to be less sensitive. We have a greater capacity, less sensitive to the acid compared to base, right? Our pH would change more if we had added more strong base here, okay? So the buffer capacity is really just saying how easily can we change it. And if our base is greater than acid, we're going to have a greater capacity to withstand acid. If our acid was greater than our base, then we would have a greater capacity for the addition of base. Okay? All right, I think that's it.